In video 6, we gave the orchestrator control over the agent loops. Now we need to examine the channels connecting those loops. I'm Mehrdad, and here's the claim I want to establish up front. The hard part is not having capable agents. It is getting them to work together reliably. That means deciding what one agent passes forward, what everyone can share, and how each receiver should use what arrives. In a multi-agent system, coordination lives in those connections, so those connections need deliberate engineering. Here's a common failure pattern. Each agent performs well when tested alone, yet the complete system still breaks when they work together. One agent omits a constraint, another ignores an earlier result, and their shared workspace accumulates conflicting notes. The usual reaction is to improve every prompt or choose a stronger model, but that targets the wrong layer. The failure is often between the agents inside the channel carrying responsibility, evidence, and intent. Before making each agent smarter, inspect what crosses that channel and what disappears along the way. That failure leads to the main idea. The connections are the real multi-agent work. A single agent already needs reasoning, tools, and context, but adding more agents creates a new engineering surface between them. Handoffs move responsibility and results, while shared state gives several agents a common view of the evolving task. If either surface is vague, successful local actions will not combine into a reliable system outcome. Design what flows between agents instead of treating communication as free-form text wrapped around otherwise finished components. Agents share information through two basic patterns, and most production systems combine them. Message passing sends a result directly from one agent to the next, which makes the path simple and traceable. It breaks when the message leaves out evidence, constraints, or status that the receiver needs to continue. Shared state works differently because several agents read and write one common workspace, sometimes called a blackboard. That shared view helps when workers need the same evolving facts, but conflicting writes and stale entries can turn it into noise. Use messages for direct handoffs and shared state for durable facts, while asking one question throughout: who needs to know what and when? A handoff should be an agreement, not an invitation to guess. In the loose version, one agent returns free-form text, forcing the next agent to infer what matters and what should happen next. A critical fact can disappear even when the sender discovered it and used it correctly. In the clear version, a typed schema names the task status, supporting evidence, unresolved questions, constraints, and expected next action. Required fields are validated at the boundary before the receiver begins its own work. This does not make either agent more intelligent, it makes missing information visible and rejectable. Treat the schema as a checklist at a critical seam, stopping incomplete work before a quiet omission becomes a wrong downstream answer. The research helps explain why this boundary matters. MAST identifies inter-agent misalignment as a major class of multi-agent failure. Agents drift from the task, ignore another agent's input, or keep useful information to themselves instead of passing it forward. Those are coordination failures, not simply failures of individual skill. Silo-Bench exposes a related communication reasoning gap where agents exchange the relevant facts but still fail to synthesize the right answer. The messages moved, yet the reasoning never combined. As the team grows, coordination overhead can also consume the speed gained from parallel work. Communication quality therefore needs two tests. Did the necessary information arrive, and did the receiver actually use it? A standard format helps, but it solves only the transport side of coordination. Think of the protocol as an envelope that identifies the sender, preserves expected fields, and delivers the message in a known shape. The envelope cannot make its receiver draw the right conclusion from the contents. That is the distinction between transport and synthesis. Standardize transport so messages remain inspectable and interoperable, then verify synthesis as a separate system behavior. Check whether the receiving agent incorporated the evidence, respected the constraints, and updated its plan accordingly. A perfectly formed message can still produce a badly coordinated system. Two emerging standards make this map easier to navigate because they address different connections. MCP, the Model Context Protocol, covers agent-to-tool communication, including how an agent reaches tools and data. We will return to that layer in video 10. A2A covers agent-to-agent communication, helping independent agents discover capabilities and hand off work across systems. These standards are complementary, not competing. MCP connects an agent to resources, while A2A connects agents across organizational or platform boundaries. Both improve interoperability, but neither defines the evidence your handoff requires, what completion means, or how the receiver proves it used the result. The protocol carries the agreement. Designing that agreement remains your responsibility. The through line is simple. Design the connections first. Handoffs and shared state are where separate agent actions become coordinated work, but they are also where systems lose information and intent. That makes the coordination layer part of the harness, not an afterthought surrounding the models. Each model reasons inside its assigned role, while the harness defines what moves between roles. It checks the boundaries and preserves the state those agents need to operate as one system. Carry 3 takeaways forward. First, the connections are the work because handoffs and shared state form the new engineering surface between agents. Second, make every handoff an agreement with explicit fields that are validated before the receiving agent starts. That turns missing facts into visible boundary failures instead of silent downstream errors. Third, delivery is not understanding. MCP and A2A can move structured information across boundaries, but the harness must still verify that the receiver used it correctly. That is inter-agent communication. Mind the gap between the agents, because coordination reliability lives there. If this series is useful, subscribe to Multi-Agent Academy, and you can also connect with me on LinkedIn. Next is Video 8 Context Management, where we will see why a bigger context window can hide the failure instead of fixing it. I'll see you there.